Okay, this is problem number 8. On this one, we want to find what direction the force of static friction is acting on the box. So first thing we'll do is draw our force diagram. We know we have mass times gravity coming down like this. So we'll go ahead and label this as the force of gravity. It's acting on the chest, so we'll make that C. And again, that's caused by the Earth. And in this case, this value will equal to the weight of the chest, which is going to be 1,500 newtons. Alright, then we would know that the force normal would be going back up, like this. We'll label this value as F of N. Again, it's acting on the chest, and what's causing this, we'll call it I for the incline. Alright, then you have an individual that's pulling up, going in this direction here. And let's see what that is. Pulling the chest is 1,000, so we'll call this the force. We'll make that a tension because it's being pulled by a rope. We will have that comma being the chest, comma being the, we'll call it the rope. And that value will equal to 1,000 newtons. Okay, right now we know we have a force of gravity. The thing is, we do not know what direction it's going. So it really doesn't matter. We'll make it go down. I think just looking at the picture is probably wrong, but it really makes no difference. So that would be a frictional force. Okay, and again, that's acting on the chest, and that's caused by the incline. So there's your force diagram. We'll label some type of axis system here. We'll make anything that goes this way be X. Anything that goes this way be Y. Okay, so there's our force diagram right here. Now, the only thing is you need to find out what these angles are. If this is 55 degrees, then this is the upper part of this triangle here, which would be right here. So we know that this angle here would be 90 minus 55, or this would equal to 35 degrees. Because 35 plus 55 gives me the 90. So what I would recommend now is I'm going to draw another force diagram. I'm going to go ahead and see if I can grab some of this. We'll slide this on down, edit, clone that. We'll drag that on down to here. Scroll down. Now what I want to do, I'm going to erase some of this. Give myself just a little bit of room. I'm going to break this one into components that are going to be parallel and perpendicular to the x-axis. So we have this going down here, so again we'll draw our vectors. We know that this component would have to go back this way. Oops, let me get a vector here. I have to go back down this way here. And this part would go back to here. Again, I'll slide that up to make it more representative of what it would be. Make it look a little bit more like 90 degrees. I'll shorten this one slightly. I'm going to go ahead and color code those so they don't blend in so well. So we'll make these two just to be red. And that's the components. Now, if this is 35 degrees, and we said up here that this was 1500, then this value would be 1500 times the sine of 35 degrees. And this component here would equal to 1500 times the cosine of 35 degrees. This one will give me the value of 1228.8 newtons. Now we can calculate this, but right now we don't need that. At this point, we can get rid of this one, and we can actually slide this back up. Sorry, slide this guy back up to here, straighten it up so it does look like it's quite perpendicular. And then again, we know that this value would have to be 1500 times the sine of 35, and that's what our F normal would be also. Alright, so now we want to determine whether we got this frictional force right here going the right direction. So I'm going to sum the forces in the x direction and set that equal to 0. Anything that goes down, I'm going to let be positive. Anything that goes up, I'm going to let be negative. So when I do this, I will get, take this value here, we'll make that positive. That would be positive 1228.8 newtons minus the 1,000 going up plus the force of friction. And again, you could make that static if you want, just put an FS there. That must equal to 0. I'll move everything to the right side, and when I do that, I will get F friction is equal to, now notice I made this positive. I made this positive only because I'm showing it going down. So when I do that, I get F friction is equal to minus 1228.8 plus 1,000. And when I add those values together, I get F friction is equal to minus 228. There we go. 228.8 newtons. Now since it's negative, I have this thing going the wrong direction. So what I can do would be, I can erase this and just say that this value must go up at 1228. Oh no, not 1228, 228. So the answer on this question would be, what direction is the force of static friction? It would be up the incline. Okay, again, by drawing good force diagrams and by sum of the forces in any direction, setting equals 0, you can determine what the direction of friction is. All right, best of luck.